So you've created your new Spring Boot microservices project, and now you're wondering where to begin. Let me show you 5 essential steps that you absolutely should take to set up any Spring Boot microservice project, even before you write your first line of code. Starting at number 1, pick a project structure. In the world of Spring Boot microservices, how you structure your application can have huge impact on its maintainability and clarity. There are basically 2 popular approaches to organizing your code, and you would likely use one of these 2, package by feature or package by layer. Let's look at these 2 and understand their philosophies, and also tell you when to use what. Package by feature means organizing your classes into packages that are based on the features that those classes implement. So for example, in your e-commerce microservice, you may have packages like users, products, orders, etc. Right? You take a package named order. Inside that package, you will find everything related to processing orders, controllers that handle the HTTP request for orders, services that contain the business logic for orders, repositories that manage database operations for those orders, and so on. Similarly, all the classes related to user management, including the controllers, the services, and the data models, all go under the user package, right? All product-related classes go to the product package, and so on. On the other hand, package by layer, which is the second approach, groups classes by their role, like controllers, services, repositories, and so on. So you would have a controller package that holds all controllers, irrespective of what the underlying feature is. Business services package holds all of the business services across these features. Similarly, data repository package contains all of the repositories. So these are 2 approaches. Now, which one is better? If you ask many senior developers, they will tell you that the package by layer style was the old way of doing things. The more modern and recommended way is to do package by feature. Why is package by feature good? It's intuitive. Let's say you want to fix something about how orders are processed. You know exactly where to look. Just the order package, right? And as your application grows, adding a new feature is as simple as creating a new package. But this is not perfect as well. Now, suppose 2 different features need to share some logic. Now, where do you put that code, right? One way is to duplicate the code in both the feature packages that need that logic. Now, you end up with a bit of duplication. Plus, when you have some functionality that kind of cuts across different features, it can be a bit tricky to manage. Okay, then how about package by layer? What's the big win there? Well, in this approach, the shared code is super easy to manage, right? If you have common logic that's used across different features, it's right there in that respective layer. But there's always a but. This approach can make it harder to work on a single feature. Now, if you're going to be hopping between packages to trace all parts of a feature through all those different layers, right? So when should you use each? If your microservice is laser focused on doing a few things really well, and you want like a straightforward, easy to understand structure, then package by layer can be a solid choice. On the other hand, if your microservice has a wide range of features, right? It's doing more than just one small, tiny thing. Well, then package by feature can help you keep those different features organized and easy for you to add and remove and tweak. From my personal experience, package by feature often feels more natural for teams working in microservice environments, right? It aligns with the microservice philosophy of having modular independent components. But if you're working on a more traditional monolithic application and you're just starting out, you might find package by layer easier to wrap your head around. And often you will see package by layer in old projects which have been created a while back, because that was the common way of packaging classes a few years back. But remember, consistency is the key. Whatever structure you pick, ensure that you stick to it. The worst case scenario is if your package structure is inconsistent and all over the place. You don't want to put 2 different styles of packaging into the same code base, and you don't want to keep going, okay, where did I put this class again? That's going to be tricky, right? So make things consistent no matter what you pick. So that's for project structure. The second thing you need to do is define service boundaries and responsibilities. When you're working with microservices, you need to know what the responsibilities of one service is and where it starts and where it ends, right? You need that clear separation. Let's say you have a monolithic app. When I come to you and ask this question, now where should code for a certain feature go? What's your answer? You'll probably say, put it in this package, in this class, package by feature, package by layer. But it's pretty obvious which project the feature should go to. It is the app. It is the monolithic project. Now we can imagine it's not such an easy question to answer when you have the whole app broken into several microservice projects. Now I come to you and ask, where should code for this feature go? The answer will be in what microservice project I should build that feature in, right? The answer is not as straightforward, but the answer can be straightforward if you build your app using certain principles and you design your microservices using those principles. And you do this by a technique called domain-driven design. At its core, domain-driven design is about aligning your software's architecture with the business domain that you're trying to build the solution for, right? So let's say you're building an e-commerce website. Identify your business domain and how the business domain is organized, right? And then you make your software architecture aligned with that, right? Think of it as a bridge between the realities of the business operations and the technical operations of software development, right? In domain-driven design, the focus is on understanding the business domain thoroughly. And this includes what the business needs, what kind of jargon they use, what kind of processes, what kind of nuances they have. So each business has its own language, so to speak, right? It's like learning that language, the language of the business, and then expressing that language through your code, right? The domain drives the design, domain-driven design. And if you do this, you don't have to reinvent the wheel and come up with architecture, right? The architecture is kind of already done for you. The business has already figured it out. They already know what the subdomains are and how they interact. You basically copy-paste that into your architecture. Easy to be an architect, isn't it? Copy, paste. I'm kidding, of course. Another key aspect of domain-driven design is the concept called bounded context, right? There is a central pattern in domain-driven design. Now, what you do here is you define clear boundaries that are set around each microservice, right? In the bounded context. It's about defining what's inside and what's outside the service's scope. Again, you will look at the domain and identify what are the boundaries for the domain entities are. So for example, the inventory management system deals with stocks and items, but doesn't do anything with purchases, right? For that goes to the purchase department. Well, then design your inventory management microservice to not have to do anything with purchases, right? Just stocks and items. Once again, copy paste what's happening in the domain. I'm simplifying this, of course, but you get the idea. It is actually a complex process, but it's such an important step to do when you're creating your microservices, because without it, your microservices will have a bit of an identity crisis, right? It's like, imagine your microservice asking, who am I? What is my role and responsibilities? What are my terminologies and business jargon? What do they mean, right? Your microservice should have answers to those questions. And the best way to do this is by using domain-driven design and bounded context. So this is the second top thing that you should do when creating your new microservice, and it is to identify your service boundaries for that new service, right? Identify the service boundaries and responsibility and the bounded context. This involves multiple steps, by the way, right? The first step is, like I said, you got to dive deep into the business domain, right? Before you write your single line of code, you have to invest time and understand the business domain that you're dealing with, right? Once you do that, you're going to move on to step 2, which is identify the bounded context. Once you have a good grasp of the domain, define the bounded context for that microservice, right? This includes deciding what to include in your service and, just as importantly, what not to include in your service, right? Be clear about the responsibilities of the service. After you do that, you move on to modeling the domain, right? With the boundaries set, you start modeling the domain within your microservice. This involves creating your classes and methods and data structures that reflect the business concepts and the business operations that you've identified, right? Notice that every step of the way, we are letting the business guide us. The final step is to design an API around your domain, right? Your microservice API is its interface to the outside world. So it should very closely reflect the domain model that you've learned about so far, right? When you're designing the API, think about how clients of your microservice will want to interact with your microservice, right? Look at it from the outside perspective. So by doing these steps, you're not just focusing on one microservice, the one that you are building, you're crafting a piece that fits into a larger ecosystem that speaks the language of the business, and it's kind of aligned with the business's processes and needs. All right, let's dive into step 3, service isolation and configuration. In the previous step, we've established clear boundaries and purpose for your microservice so that when there is a new feature that comes in, only the relevant features affect your microservice, and those things are incorporated. The things that are not relevant aren't affecting your microservice. However, this particular step, step number 3, is looking at it the other way. How can you ensure that whatever changes you make to a microservice doesn't affect other services unless it's absolutely necessary? This is where we ensure that our microservices are not only self-sufficient, but they're also adaptable to change without causing a mess in like the entire system. Now you might ask me, hey Kaushik, we've got microservices that just expose APIs. So as long as the APIs are constant, how does it even matter what change you make inside your service? Well, you'll be surprised how internal service changes can affect things outside this, right? There are a couple of things you can do to ensure that it doesn't happen and your services are isolated. First up, independent configuration. Each microservice in your architecture is like an individual piece of a bigger jigsaw puzzle, right? You want to make sure that you can tweak and configure your microservice independently. You do this by allowing each microservice to have its own set of configuration settings, which can be changed on the fly without needing to redeploy the service, right? Imagine you need to tweak a database connection string, or you need to update an external API key. With independent configuration, it's as simple as updating a configuration file in a central place, and your microservice picks up the change. This setup makes it very easy to manage configurations, and it also adds a layer of resilience to your system, right? If one system needs a change, it doesn't mean that you have to bring down the whole system just to get that to work, right? That's the first piece of making sure that changes to your microservice doesn't affect something else, right? The second piece, which often gets overlooked, is the database. When you create a microservice, you ideally should also create a database. Yep, you heard me right, database per service. In a traditional monolithic app, having a single database is so common, right? It's a no-brainer, especially if it's a relational database. You put all the data into one relational database server. But in the world of microservices, having all of your microservices interact with the same database can be, well, tricky. It can work. I'm not saying it's impossible, but it is far from ideal, right? The pattern of having separate databases for each microservice is about giving each part of your system kind of like its own voice, its own storage mechanism, right? This approach has a couple of standout benefits. First of all, it encourages loose coupling. Your order management system doesn't need to know or care about how the inventory management system stores its data, right? It can evolve independently, scale independently, and if necessary, even fail independently without causing a domino effect. Secondly, it aligns perfectly with the concept of bounded context and domain-driven design that we talked about in the previous step. Each microservice manages and owns its own data, leading to cleaner and more maintainable architectures. But of course, this approach is not without its challenges. It can add complexity in terms of data management and consistency, and you need to have a good strategy for handling transactions that span multiple services. But this needs to be done. You can't just create a new microservice without thinking about how you're isolating your data as well. You don't want to be thinking, okay, I'm going to make a schema change. Which microservices are going to be impacted? Well, you run into that problem when you have multiple microservices talking to that same database per service, and that answer is much more straightforward. All right, moving on to step 4 in setting up your new Spring Boot microservice project is all about inter-service communication. This is where you figure out how your microservices are going to talk to each other. It's like setting the rules of a conversation, right? Who talks to whom and how. The first decision in this step is choosing communication protocols for your microservice. The world of microservices, you've basically got two styles of communication, right? Two types of communication styles, synchronous and asynchronous. Synchronous communication is kind of like a phone call, right? One service calls the other and waits on the line for a response, right? This is where protocols like REST or gRPC come into play. REST is widely used thanks to its simplicity and compatibility with HTTP. It's great for request response. gRPC, on the other hand, is like REST's more efficient sibling. It's based on HTTP2, it supports streaming, it's really good for high performance scenarios. So that's synchronous. And then there's asynchronous communication, which is more like sending a letter. One service sends a message without waiting for an immediate response, right? That's where you have messaging systems like AMPQ and Kafka. They are perfect for scenarios where you need to kind of decouple services to ensure that the messages are processed eventually, even if the recipient isn't immediately available. Kafka, for instance, is great for handling like high throughput and scalable message processing. So you need to look at your service and decide, is the API of my new microservice best suited for synchronous or asynchronous style of communication? Does the consumer of your API need the response right away? If so, your API needs to be synchronous. Or is your API more of like a send and forget kind of a deal? In which case, you can go for asynchronous. Of course, you can have multiple APIs in your microservice where some are synchronous and some are asynchronous. You have to make the decision based on what the API is doing, really. Now, another important factor with inter-service communication is service discovery integration. Right? In the microservice architecture, you've got a bunch of services that need to be aware of each other. Service discovery is kind of like a contact directory of your microservices. It's how they find out about each other's existence and location. So you have tools like Eureka, which come in very handy here. When a new microservice is spun up, it registers itself with Eureka saying, hey, I'm here, this is how you can talk to me. When another service needs to communicate with it, it asks Eureka where to find it, right? This setup kind of simplifies the process of scaling and maintaining your services as they kind of come and go, right? And the rest of the system will still know where to find them. So when you create a microservice, you have to make sure that your service registers with whatever service discovery mechanism that you have. So two things about inter-service communication. First is identifying the communication protocol, synchronous or asynchronous, and of course, service discovery mechanisms. This is something that you need to do when you're creating a new microservice. All right, we made it to step 5 in setting up your new Spring Boot microservice project, monitoring and health checks. This is where we need to ensure that your microservices are not just up and running, but also healthy and performing as expected. First on the agenda, logging and correlation IDs. When you're working with a monolith, you have a single source for logging and debugging and tracking what's going on. But with microservices, you have each microservice writing to its own log file. So tracking what's happening can be like trying to follow multiple conversations. Like if you're in a party and you're trying to follow what each person is saying, it can be messy. Each service is doing its thing, and when something goes wrong, you need to kind of piece together the story from different sources. That's where consistent logging practice comes in. It's super important that all your services log their activities in a standardized way, so that when you're looking at the logs from different services, you're not trying to decode what went first, what the heck is going on. And this is where correlation IDs can help a lot. They're kind of like name tags for your request. When a request enters your system, it gets a tag associated with it. It gets a unique identifier. And as it travels through the different services, each service logs its activities along with this ID. This way, when you're looking at the logs, you can filter out by this ID and see the entire journey of your request across these services, right? So you have kind of like a whole story behind the request, telling you where it's been and what's happened along the way. Next, let's talk about health check APIs. Just like us humans, your microservices need regular health checks to ensure that they're functioning correctly. This is where something like Spring Boot Actuator comes into play. It's actually a Spring Starter dependency that you can add to your Spring microservice, and it kind of allows you to expose health check endpoints for your services. These endpoints can provide really important information about the health of your service. Is it up? Is it struggling to connect to a database? Is it running out of memory? You can call these actuator APIs to access all of this information. And of course, you can customize these checks to be as simple or as detailed as you want. And especially when you're running these services in a containerized environment, these health checks become even more critical. They can be used to detect readiness, right? They can be used as liveness probes, right? When you're spinning up microservices in containers, the service orchestrator needs to know when a service instance is ready so it can start sending traffic to it, right? Readiness probes tells your orchestration tool, all right, this service is up now and ready to start handling traffic. Similarly, there are liveness probes, which let the orchestrator know if a service is alive and working. If a service fails, its liveness probe request fails and the orchestrator tool can automatically restart it, for example. So monitoring and health checks are super important. You have to spend some time and think about how they work in your microservices. If you already have a system and your microservice is now being a part of that system, you could probably just use whatever other microservices are doing because you want to be consistent there. But take some time and look at this. It pays dividends later, honestly. So there you have it. 5 things that you have to think about with your new Spring microservice before you even write your first line of code. And when it's time to write your first line of code, you need to know the stuff that I cover in this video. Check it out.